factoring trinomials. Now, what we saw last time with factoring by grouping, that's all. We're going to force it to become 4 terms from the 3 terms, but we're going to do it with purpose. We're going to do it through stratagem. Now, the nice thing that with what we're starting with is that the coefficient of the x squared is just going to start out as a 1, right there, as a phantom 1, which is going to make things really nice because all we got to do is focus on these. This would be the constant, and that would be the coefficient of just the x. So what we do is we look at the factor pairs for C, not prime factorization. Don't get the two confused. Factor pairs for the C value, even if it's negative, okay? And we want to find a factor pair which, when we add them together, we get the coefficient of B. What that tells us is the 2 values that we need to separate this one into. Now that's if we were to factor by grouping. Once we show a factor by grouping, we're going to take a shortcut because once you find a factor pair from the constant that adds up to the B value, then you can actually just replace these into the 2 binomials. So it is a nice shortcut, but I'll try to relate it to factoring by grouping because eventually we're going to, once we have a coefficient of the x squared, we're going to have to factor by grouping anyways. So again, I'm looking at factoring by grouping, okay? And but I'll do this twice just because it really isn't too bad, right? 6 doesn't have a lot of factors. So here's the way that I set it up, okay? So I say, look at 6. I'm looking for factor pairs. Now this kind of sets up, it looks like a factor tree, but I've split it up twice, specifically because I want a pair. And then I'm just going to list the pairs as I go down right here. Now I'm purposely going to list probably more. Well, it is going to be more than we need, okay? But I want you to see that you have to consider all factor pairs when you go through this. But remember, I'm gonna list them, and then we'll figure out which pair adds up to 5. And I think it'll be pretty obvious once we get there. Now for 6, usually students will start out by thinking, well, 2 times 3 is 6. That is a factor pair. Factor is multiplication. What 2 numbers do you multiply to get 6? 2 and 3 works, but this is kind of a crucial one because it happens from time to time. 1 and the number itself. Okay. Now some students would say, well, Sal, you're done. You don't need any more factor pairs, which is true. But again, I'm going to show them. And then some students are like, yeah, but there's not any more. There is. Because if I were to make this -1 and -6, if I multiplied these 2 together, I would still get +6. Okay, so we need to consider not just the positives, which is usually what we do with factor trees, but now the negatives as well. So really it's the same list, just now the numbers are negative, okay? I'm going to go through these as well. I'm going to go through all of them because we're looking for one of these pairs to add up to the middle coefficient 5, right? So I say right here, 1 plus 6, boom, that's 7. Now I know that's not gonna work. And I'm purposely going to skip the next one because, well, you'll see why. But -1 plus -6 is -7. And then -2 plus -3 would be -5. Now some students say, oh, look, you got a 5 right there. That's true, but this is a +5. Remember that all the terms take the operation to its left. And that's why I skipped that one, because 2 plus 3 is 5. Okay, so 2 plus 3 is 5. That tells me that the middle term, so this is what we started out with, x squared plus 5x plus 6. The middle term I can split up into those 2 factors, 2 and 3. This tells me how many x's there are. So what I just did right there is I took 5 x's and I split it up into 2 values that combined would give us 5 x's. Same value of 5x, I just wanted to see it different, which is usually, it's actually a huge deal in math if you can start to learn to make things do what you want them to do. Things turn out pretty well, okay? So that's what I've done. Well, the rest of the expression, we got the x squared, that was a positive 2x plus 3x plus 6, right? And now you see, I took that trinomial And now that I have it into 4 terms, I can now factor by grouping. Well, if I was to factor by grouping, I would group these first two. And what could I pull out from those two? Looks like I could just pull out an x. Okay, fair enough. If I pulled out an x, then the first term would be left with an x, and the second term would be left with a plus 2. Okay, the second set, 3x plus 6, looks like I can pull out a 3 from both of those. And then the x just has to stay, right? So I pulled out a 3 from the first term, so I have the x. You can make it 1x if you want. And then the plus 6, I pulled out a 3, so 6 divided by 3, boom, 2. And I was expecting this to be plus 2, by the way, because this one was plus 2. So that's the beauty of finding the factor pair that adds up to the middle coefficient. It allows you to factor by grouping, and it'll work out very nice. So now that I have that, from those two terms, I'm going to factor out an x plus 2. And then the other set of parentheses is just what is left over, right? So I have the x from the first part, and then I got a plus 3 in green there from the second part. This is the factored form of this trinomial. Now, what I was trying to show on that last slide was pretty much at this point we could have been done. Once we knew that 2 plus 3 is the middle coefficient of 5, we could have just said, hey, look, let's set this up. Okay, that's what that last slide was saying. It's x, and then just put in the two factors, which were plus 2, positive 2, and positive 3. See, these are exactly the same, and it skips a lot of this work right here. This method right here, it's going to work all the time because sometimes there's a lot of rules, right? So I can't memorize this crap. Okay, then just factor by grouping, which is, it's always going to work, including when the coefficient of x is not a phantom 1. So this one, all I'm going to do is I'm going to take the shortcut on this one, all right? Now, if you want to factor by grouping, feel free to do it. But we're going to get plenty of opportunities to factor by grouping today. So remember, this sets up, and it specifically is because the coefficient of x here is a phantom 1. I get to put my x's in here. All I need now is two factors of 1 that add up to 6. I'm pausing for dramatic effect because the only factors of 1 that I can think of are 1 and 1, and also negative 1 and negative 1. Now, the unique thing about these is if I add 1 and 1, I get 2. If I add negative 1 and negative 1, I get negative 2. I can't add anything up right here to get 6. So this one we just say it cannot be factored. Yep, cannot be factored for this one, and we'll underline it for dramatic effect too. Now that we've seen that, so this a right here indicates that the coefficient of x, sometimes it's not a phantom 1. So you may see a coefficient of your x squared, which is what the a is representing. Right? A, b, and c, these would be numbers somewhere in the expression for us. So what we're going to do is we got to take the a and c value. We're going to multiply those two values, and we're going to find the factor pair from the a times c, whose sum is still the center coefficient, the coefficient of x. Once we get that, then we will factor by. We're going to split the middle term up into those two specific factors, and then that will allow us to factor by grouping, which when we do, it should work out very nice. Just be careful because sometimes, especially with these coefficient of x squareds that are not phantom 1s, sometimes you may factor out a 2, but you should have probably factored out a 4. Okay, so just always double check in the end to make sure that there's no other factors to factor out. This middle one, right? Again, this goes back to us. We're going to change this center term into two separate terms, but they're going to always add up to this one, and that comes from this finding the factor pair that adds up to b. All right, so for this one, and I probably should have mentioned this before, we don't really have the form right here that we just saw, right? It was saying ax squared plus bx plus c. The problem here is that it's an x cubed leading term, right? Then we got an x cubed. So right here, we got 56x squared and then plus 180x. Yeah, from that we can factor out an x from all three of those terms, not even just the x, right? The other thing I notice is that the coefficient of x cubed and the x squared and just the x, these are all even. So I should at least be able to factor out a 2. Possibly more, okay? So that's what I'm gonna do. Let's yeah, I think so, right? So I'm gonna start with the x because it's the first thing that I notice, which usually with the variables, once you get enough experience with this, the variable becomes the easier of the two. So I'm going to factor out an x. Okay, now from each of those terms, the x cubed now becomes, from the first term, is an x squared. From the second term, the x squared becomes just an x. And then the last term here, we took this x out. Okay, so we factored out, we pulled out an x from each of these three terms. This is what we're left with, but like I said, we should be able to factor out not just a 2, but yeah, we should be able to factor out a 4 from all 4 of these, right? So I'm going to also factor out a 4. From the first term, if I factor out this 4, if you want to show that 1, that's fine. I mean, just to kind of relate it to what we've seen already, I'm going to make it a phantom 1 though. And then we got 56 divided by 4, which would be positive 14. And then 180 divided by 4 would be 45. Thank you. Yeah, and that looks good. Now, the good news here is that we factored that out, and
You can factor more.
yes, yeah, we can factor more at this point. Yeah, so, but now, just the way that we have this, the coefficient of x squared is a 1. So, I'm going to skip the factoring by grouping, and I'm going to set up my two binomials with the x's, like this. And all I got to do is find 2 factors of 45 that add up to 14. Now, I'm going to go through these one by one. But once I find the one that is 14, then I'm good, right? Now, yeah, so some of you guys know what it is. I'm gonna go through some of them here. So there's a, all right, so then we got, it would have been 1 times 45. Now, 1 plus 45, of course, isn't gonna work. I can't divide by 2, I could use 3. 3 times 15, 3 plus 15, those 18, which is pretty close to 14, but it's not exactly 14, right? Can't divide by 4, but 5 would work. 5 and 9, boom, we found it. Okay, now I went through the positives, which I usually will do. If this number were negative, then I would have to have one be positive, one be negative. This one's positive, so I just went through the positives. If I didn't find any positives that worked, then I would have to go into the negatives. But I found one that does work, so I can fill in those values. I got a positive 5, and I got a positive 9er. Now don't forget the 4x that was out there in the front, right? So it's this full expression right here. Now yeah, so from this original, you could have factored by grouping, even with the x squared stuff. Now, just like we would, and kind of showed in that last slide, we pretty much ignore the x squared. But what we need, kind of here to start with, is the leading coefficient 4, and then multiply it by what would be the, in this case, it's a coefficient, but it should be a constant usually. And if I was prepared, I'd have my calculator out. But 4 times 180, enter, 720. So the multiplication of these is 720. Now what we need is a factor pair of 720 that adds up to 56. Now instead of doing this factor pair by factor pair, let's skip a little bit. So the first one that I was thinking of was 72 and 10, and that's pretty nice. But if I add those together, it's 82, right? But it's close. It's fairly close to 76.
76?
Sorry, 56. I was close. We'll say that I was close. Thank you. Thank you. All right. So we're going to take 720. Let's divide it by, let's try 20. That's 20 and 36. Now, I literally was just fishing right there, but I found it. 20 plus 36 is 56, right? So, again, if you didn't notice, the greatest common factors, which we just did, you could have said, I found 56, which means that the middle term you could have split up between 20x squared and also 36x squared, right? That's positive. These are positive, by the way.
It seems like this way you're taking.
And then we do have the rest of it, right? We got 4x cubed, and then we got the positive 180x. Okay, now, again, we took a trinomial, we factored it into 4 terms, or we split it into 4 terms, and now we're going to factor by grouping. So from this first set, I'm just going to focus on one set at a time. I know I can factor out a 4, and I can factor out an x squared. What I'm left with from the first term is just an individual x, and then we got 20 divided by 4, which is 5, and I took out both x squareds right there. You see how it's already forming with the one that we have to the left. All right, so that's that one. Now, of course, the next one, I'm leading us into this, but I'm expecting this to be factored into some kind of x plus 5. Let's see if it works. Okay, so I'm looking at 36x squared and the 180x. I can factor out an x from these. So it looks like we should be able to factor out 36. Some students say, how do you know it's going to be 36 right here? Because I'm expecting this to be 1x, and right now it's a 36x squared. So I should be able to factor that 36 out. Let's find out, though. I'm going to use my calculator. 180 divided by 36. Enter. Boom. It works. So 36 can be factored from both those numbers. So here's what happens from here, though, is that from these 2 terms, I can factor out an x plus 5, which we can see in the answer. But what I'm left with is from the first term there is 4x squared, and then the second one is a 36x. So it doesn't quite look like the answer that we got, but we see that this second binomial that I have can be further factored. So setting aside the x plus 5 right there, let's factor out from there a 4. So 4 divided by 4 is 1. 36 divided by 4 would be positive 9. And then also the x. So then we got an x left over from the first term. We took the second one out, and just writing this a little different, now I will apply the x plus 5. And we see, well, once I get rid of that, I'll just make it a phantom 1. Now we see that we end up with the same answer.
Well, you just reverted it.
So the last thing you should always do with these is check, right? Because some students, here's one of the mistakes we see with problems like this. Students stop right here. Right? Hey, look at all this factoring that I did, and it felt good, but you could have factored more. Okay, so just be careful on that. Always check your answer. Make sure, like the x plus 5, of course, there's nothing we can do there. You can factor out 1 many times if you'd like, but it's in this one, right, that you could have factored more out. And yeah, so this one, I have the x plus 5, then x plus 9. This one, x plus 9, then x plus 5. That doesn't matter. It is exactly the same answer, just in a different order, and that's okay. So you can see, through this process, there is the opportunity to make mistakes, which I've done as well. And we should get used to it because we're just practicing, right? So get used to making mistakes and then needing to go back and check. But yeah, you can check this by just simply distributing. For example, the 4x into the first parentheses and then using, I would say distribution, but FOIL, and then making sure that you end up with the same original expression that you start with. Now, be careful because just like we showed with that last example, you could just do 40 times 12 and it's like thumbs up, right? But you should always check for greatest common factors. And right here, I can see that we can reduce these numbers specifically because they're all even, right? So I'm going to do that first. Now, whether you factor because I'm going to factor out a 2, with 4, thank you, 4. I'm going to factor out a 4. Whether you factor out 2 or 4, right now or later, it should happen. It has to happen eventually because it's part of the factoring. So let's factor out our 4 here from each of these terms. And I can't factor out an x from each term, so I'm not worried about the x's. But the 4, yeah, no problem. Let's factor out a 4 here. So the first term, 40 divided by 4 would be 10. We'll keep the x squared. 68 divided by 4 would be 17x. And then 12 divided by 4, I can do that one in my head. It's a 3, so I feel good. Okay, so that just makes the number smaller, because if you did 40 times 12, 480, yeah, there's a lot of factoring there, lots of factoring. But it still works. It still works. You can still factor by grouping from that, but by factoring out the greatest common factor to start with, it makes the factoring by grouping now, in my opinion, much easier. Because we're going to take the leading coefficient 10 and then the constant 3 and multiply these to get 30. So I'm just looking for factor pairs for 30 that add up to 17, right? Now, I know some of you guys know what it is, but I'm going to run through this, not to be redundant, but just for practice. So I would start with 1 and 30, which when I add together is 31, so it's not 17. That's no good. 2 and 15, boom, we found it. So that didn't take very long. 3 and 10, of course, wouldn't work. It's close. But I do know that 2 plus 15 is 17. So you could factor, well, we're going to have to factor by grouping. So 17x, I'm going to split it up into those two factors, 2x's and, by the way, it's positive 2x's, and then positive 15x's. Now, I'm going to not worry about the 4 right now. I'm going to apply it to my multiplication later. But my full expression right now from inside the parentheses, 10x squared plus 2x plus 15x plus 3. Okay, now I took the trinomial, and just like we saw yesterday, I'm factoring with a 4-term polynomial, which means I should be able to factor by grouping. So let's factor by grouping because it's so much fun. And my first set of parentheses here, I can factor out, looks like a 2x right there, right? So the 10 divided, sorry, I should focus on one part at a time. Let's focus on just the 2. So if I factor out a 2 from the 10, I get a 5. If I factor out a 2 from the 2x, it's just, you can show the 1 if you'd like. I'm going to get rid of it later, though. But then I would focus on the letters, so I got the x squared and x. I can factor out an x from both of those. From the first term, we have an x left over. The second one, looks like I need that 1 right there. Because I factored out, from the second term, I factored out all 2 x's right there. So I'm just left with the 1. And then the second set here, looks like from that I can factor out a positive 3, specifically from the 15 and the 3, right? So 15 divided by 3 is 5. 3 divided by 3 is 1. And then we keep the x with that first term. Now, I didn't specify this first. Were we expecting this to be 5x plus 1? Yeah, we were, because this one was also 5x plus 1. So what do we get? And I'm still working within that parentheses. I'm just not showing it yet. I will, just not yet. So from those two terms, I can factor out a 5x plus 1. But what's left over? Well, the first term had a 2x left over, and the second term had a positive 3 left over, and that would have been working from inside the parentheses. So I can apply the 4 there. But the parentheses now are kind of a redundancy. So just to make it look pretty, let's get rid of this garbage. And now even the 4 is kind of far away right there. If that bothers you, then you're a math nerd. But you can put multiplication if that makes you feel good. You just don't have to. And I really don't care about distance right now. If it's way over here, that'd be a problem. But I can see that this was being applied. So if you had kept everything the way it was, you would have kept parentheses here and here. And then you would have shown the 4 throughout the problem as well. But I don't really recommend doing that, because having the 4 there, sometimes it causes confusion for students. Like, what the crap is that 4 doing there? We yanked it out earlier, and it's okay for it to be there, but I like to wait till the end to reapply it to the expression. All right, 6x squared plus 7x plus 2. You guys try this one. Take a minute and try it out. So this is the first problem we see where there's no greatest common factor to yank out, at least from the last 2 problems, right? So this one, we're just going to deal with it as is. No greatest common factor. So I am going to take the leading coefficient of 6 and the constant 2, and we're going to multiply them, right? So 6 times 2 is 12. So I'm looking for 2 factors of 12 that add up to 7. So I say, well, okay, let's see. 1 and 12 is 13. That doesn't work. 2 and 6, close. It's 8, but still doesn't work. It has to be exact. All right, 3 and 4, we found it. And again, if this was like a negative 7, then both these would have to be negative. Just keep that in mind. So from the 7x, I'm going to split this up into 3x's, positive, and positive 4x's. Now some students get caught up, they're like, what if I want the 4x right here? Do it. I don't care. You're going to get the same answer from this factoring either way. So the first term there, though, let's put in the rest of it. 6x squared plus 3x plus 4 plus 2. So our trinomial now is a 4-term polynomial. And now that we have that, let's go and factor by grouping. So the first pair here, I'm going to factor out, looks like just from the numbers, I can factor out a 3. So I'm focusing on the numbers first. 6 divided by 3 is 2. 3 divided by 3 is 1. But then I see that I've got an x squared and an x, which means I can factor out an x from both terms. So the first term still has an x. The second term, we pulled out both the 3 and the x, so we do need this 1 right here. So that's factoring from that first part. Now we'll factor from the second 2 terms. And it looks like we can factor out just a 2 from both of those numbers, the 4 and the 2. I can't factor out an x here, so I am expecting 2x plus 1. 4 divided by 2 is 2, then we keep the x. 2 divided by 2 is positive 1. So it does match. So from there, I have factored out, from these 2 terms, I factor out a 2x plus 1, and then I just write in what's left, right? So the first term had a 3x left over, and the second term had a plus 2 left over. Now again, just before you finish here, just make sure there's nothing you can factor, some kind of greatest common factor with each binomial separately. I don't see any. So it looks like this one's done. And again, if you wanted to write this as 3x plus 2 times 2x plus 1, it's the same exact thing. All right, so this is a good point. If you reverse the 4x and the 3x right here, right? So I'm skipping the first part. You're going to get the same answer, and here's how. So the first 2 terms, now I can factor out here a 2 and an x. So I'm skipping some of the math here, but that leaves me with the 3x. And then from the 4x, we factored out a 2 and an x, so we're just left with plus 2. And then we got this other one right here. Now, there should be something that's factored out, right?
1.
So, yeah, but there's nothing. Yeah, there's nothing to factor out right here. We do need to see something factored out, so that's, yeah, we'll just show it as a plus 1 factored out. And now it does match, a 3x plus 2. So, because some students are like, well, it already matches right here. That's true, just factor out a 1. And now I factor out a 3x plus 2, and I'm left with the 2x plus 1. So thanks. That was a good example to show that, because if you get to the point where you can't factor out anything, factor out a 1, and you'll see that, again, it's the same exact thing, just now the order's changed, just the way that I'm writing it. So this one right here, some students are like, oh, what the crap is going on with the y's on this? How can you have x's and y's? You can. It's just factoring by grouping, which you've noticed, right? When we factor by grouping, which we just did and have done, we pretty much ignore the letters, right? Like the first example we had, you could have factored out an x, but if you factored by grouping, it didn't matter that there was an x on all terms. So even though there's x, y, and then a y, none of that matters. What we're going to do is just go through this process, right? So I take the leading coefficient of 5, and then I multiply it by the last coefficient, in this case, negative 4. So 5 times negative 4 is negative 20, and what I need is 2 factors of negative 20 that add up to negative 8. I think, I don't know what the crap happened there, but let's try this again. So 1 and 20, thank you. So negative 1 and 20, still no good. It still doesn't work, even though I did it wrong the first time, but 1 and negative 20 still doesn't work. What? It still doesn't work. So this is no good, and now we'll try, it's 2 and 10. Let's make this a negative 2 and 10. Now it's positive 8 though, right? So all we got to do is reverse this to get our negative 8. Okay, so if I add those two together, I get negative 8. There are more factors, I just don't care about them because we found the one that works. So our negative 8xy, I'm going to split into a positive 2xy, and then also a negative 10xy. So you see, again, that these two terms add up to negative 8xy. We're splitting the negative 8xy. You could say, well, I want to split it between negative 1xy and negative 7xy. It just doesn't help you. Okay, so you could do whatever you want right here, but we want to do it with purpose, which is what we've just done. And now I'll rewrite the rest of this. I got 5x squared plus 2xy minus 10xy minus 4y squared. And we'll start factoring by grouping. So I'm going to group the first two. And right here, it looks like I can only factor out an x from these two terms. So that leaves me with 5x and then a positive 2y. Now that, some students are like, how the crap can you have an x and a y? It doesn't matter. All I could do is factor out an x. So that's just what I'm left with. And that means also that I'm expecting this one over here. When I factor, I'm expecting a 5x plus 2y. So let's see what happens. So I'm going to factor from, it's a negative 10 and a negative 4y squared. I can factor out, first I'm going to factor out a negative, specifically because it's starting out as a negative there in front. And it looks like I can factor out a 2 and a y. So what am I left with? Well, negative 10 divided by 2 would have been 5. And then the negative 4 divided by negative 2 would have been positive 2. And you see it's already starting to match what I have there in purple. And then the first term we factored out a y, so it's left with the x. And then the second term we factored out one of the y's, so we're still left with y. They match, which is, I don't know, kind of convenient. But now from these two terms, I'm going to factor out a 5x plus 2y. And then I'm left with an x and a negative 2y. Now again, since there's this kind of funky looking, I'd say, is there anything else I can factor out from these? No, there isn't. And you may have noticed that from the beginning. There was no greatest common factor to factor out from all three terms, which is what we need. It has to happen with all three. And again, if you reverse this, x plus 2y times the 5x plus 2y. Sorry, let me start that over again. X minus 2y times the quantity 5x plus 2y. It's the same thing, it's just written in a different order. So let's do this one, right? So we'll factor out, I think I used purple, didn't I? From the first two, we can factor out a 5 and an x, which leaves me with just an x from the first term, and then negative 10 divided by 5 is 2. We took out the x, but we're left with the y. And you can see, right, we got the x minus 2y, which we have in the answer. There it is, right there, right? And then we can, from this second set, we can factor out, it looks like a positive 2 and a y, which means we're left with, from the first term, the x. And then negative 4 divided by 2 is 2, and we took out one of the y's, so we got minus 2y. So it definitely matches. We can factor out from those two an x minus 2y, and then we're left with, from the first term, 5x, and from the green, the positive 2y. So it is exactly the same, just in a different order, and that's fine.